Alright, so now I'm going to do numbers 1 and 2 kind of together because they both involve graphing. Number 1 is graphing an exponential function, and I know that because the x is in the exponent and it doesn't have the word log in it. So I'm going to use my graphing calculator for this, but I can find out a lot of information just from looking at this problem. So if it's exponential, remember that's the one that has the horizontal asymptote. So my asymptote is y equals, and that affects the range. So my asymptote, without anything being done to it, was at y equals 0, but this one has been shifted down 5. So because it's been shifted down 5, my new asymptote is going to be y equals negative 5. So I'm going to go ahead and draw that here. And again, that comes from this minus 5 at the end. I need to determine whether it's growth or decay. And so I'm going to look at the number that's the base, whatever is being taken to the power, which in this case is 3. So because that's a number that's bigger than 1, the answer to this is that it's growth. If this was like 1/2 or 2/3, something between 0 and 1, then that would be decay. So the domain, because this is still facing up, like this is a positive number, so my exponential growth would be going up. Then it's actually been shifted down here, but because it's going up, then my domain is actually negative infinity to positive infinity for these, so that doesn't change. And I'll show you how to get all this from the calculator. But it's negative infinity to positive infinity, or you could write it with the fancy brackets and set notation. And then the range has to do with the vertical asymptote because it gets really close to negative 5, but it doesn't actually touch it, and it's above this. So it's from negative 5 to positive infinity. And I don't use a bracket, I use a parenthesis to show that it gets close to negative 5, but it doesn't actually touch it. And then I would put y is greater than negative 5, not greater than or equal to. For that same reason, it gets really close to negative 5, but it doesn't touch it. So I actually pulled all of this information out without graphing it in the graphing calculator, just from the problem. But let's look at the graphing calculator to try to pull the rest of it out and go from there. So when I do this, let's see, it's y equals 1/2. Here, I'm going to go ahead and type it in the calculator so you don't have to watch me. So when I graphed it, it looks like this, and this is what comes up on my thing, and you can see that the asymptote is down here at negative 5, and so I can actually go and look at that in the table and see the same thing. If I go to the table and I go down here, you see that it's rapidly approaching negative 5, and then it says negative 5 in here, although it's not actually touching it, because look, this decimal, as it gets closer and closer to negative 5, eventually your calculator is just going to round that. So y equals negative 5 is the horizontal asymptote, and then I'm just going to look for other numbers that I can plot on here in order to do that. So the domain, you can see, is going off from negative infinity to positive infinity. The range goes from here, my asymptote, negative 5, up forever. And then the other question was growth or decay, so it looks like exponential growth. And I need to make sure when I graph this, I drew arrows here. So what I'm going to do now is I'm going to look at the table, and I'm going to pick 3 points to graph. So I'm just going to kind of snip this table so you can see where this information is coming from. Alright, so here's what I had here on my paper just from looking at the function, and then here is the table that I was given whenever I graphed it in my graphing calculator. So I'm going to go through and I'm just going to pick some of these points and plot them. They're not going to be exact. You're going to have to estimate because obviously these are not whole numbers. So I would plot a point at 0, negative 1/2. I would plot a point at negative 2, negative 9/2, which is like negative 4.5. And then I would plot a point at negative 1, negative 3.5. I could do that. Positive 1, 17/2 would be 8.5, which is way up here. Okay, so that kind of gives you an idea of where some of the points are. You won't actually touch this asymptote. You'll get really close to it. and then it shoots off like that. So that would be the sketch of my graph. And again, I can see that the domain is going from left and right, from negative infinity to positive infinity, so it's all real numbers. The range goes from here up forever. And the horizontal asymptote is at y equals -5 because that's where it's reaching but not actually touching, and it's exponential growth because of that being a whole number that's bigger than 1. It doesn't have to be a whole number, but anything bigger than 1. Okay, so now when I'm looking at number 2, I'm looking at a log function, and remember that there are errors whenever you try to take the log of 0 or a negative number. So that would affect my x value. So that's how I remember that this asymptote is going to be x equals, it's going to be a vertical line. Because again, that's an issue whenever what's inside here is 0 or negative, and I can see that it's in there with an x. So that will remind me that my asymptote is x equals. And so this function right here has been shifted left 2 and up 4. This doesn't actually affect my domain, only this does. So it's gone left 2, which means my vertical asymptote, instead of being x equals 0, is at x equals -2, which is right here. And I can tell that, again, just by looking at the function. So that's the asymptote, x equals 2. I can tell the domain from that because it's going to be on this side of it. And so instead of going from 0 to infinity, it's going from -2 to positive infinity because it's going from there to right forever. And we already said it wasn't going to pass this line. So the asymptote is x equals 2. The domain is the one that's affected, and it won't go past this line. So that's the one that the domain would be from 2 to infinity. And again, it's a parenthesis showing that it gets really close to 2, but it doesn't actually touch it. And then in set notation, I would say is greater than 2, not greater than or equal to, because it can't actually touch, again, the asymptote. The range on these went from negative infinity to positive infinity. And so it's, for all my y's, y is all real numbers. It's everything. Because it does go down forever and right forever, even though it starts to kind of slow down. I'm sorry, down forever and up forever, even though it starts to slow down towards the end. So we're going to look at our graphing calculator and figure out how we can plot those 3 points and figure out that information from that as well. So when I get to my graphing calculator, I'll pull that up here, and I'm going to graph it. And when I type it in y equals and I graph it, it looks like this. But this is not actually what it looks like, so we'll talk about that in a second. This right here starts to make a very steep, very vertical looking line. So it comes down here like this, and your calculator won't make a vertical line. So if you remember, x equals -2 is the asymptote, so it gets really close to this, and you see how your calculator looks like it's getting close to it, so it's going to look almost vertical. It's not actually vertical, it's still going left a little, but it's by like fractional, very small margin. So your calculator, it looks like, is doing that, but it actually continues on here. So I'm going to figure that out again from the table. So if I go and look at the table, I'm going to see -2 gives me an error. That's where my asymptote is. X equals -2, which I already knew that. And then there's a point here at -1, 4, so I'm going to plot that. And then there's some other points here I could estimate, or I could try to kind of estimate 8, 5. So that's what I'm going to do. And so I kind of pulled up both pieces of information on the screen, the table I was just looking at, and this. And so this is a -2, I apologize. This should be x equals -2, which I graphed over here but didn't write down. So x equals -2 is the asymptote, that's the error. And then I've got a point here at -1, 4. -1, 1, 2, 3, 4. So I'm going to pick the whole number, but you don't have to. You could pick 1 and 4.5 or whatever else and kind of estimate that. 6 is about like 4.9, so it's really, really close to 5, but it doesn't quite touch it. And as you can see, it continues to go up. So that's where I'm getting that the range goes off to infinity, because it's going to eventually pass 5 and go up. It's just going up at a very small margin. It's not bumpy like this. It's really hard to draw something like that, but that's the idea. Okay, and then my calculator looks like it does this, and then it just stops. So what's happening is, past this point, it's pretty steep and vertical looking, so it goes down like that, but going more towards the left than what I'm drawing, because it's not that easy. But that's the sketch of the graph, and that's what that looks like. And so I can tell by looking at the graph in my graphing calculator that my domain is from -2 to positive infinity, because it starts here at -2 and it goes off forever, but it doesn't actually touch -2. So I apologize for not putting negatives on there, but it is a -2.